What's up, YouTube? We're here doing another PE environmental practice problem today. Today we're going to do problem number 4 from the PE environmental practice exam. This problem asks that a wastewater treatment plant discharges to a receiving stream. After mixing of the wastewater effluent and the receiving stream, the following data applies. We have 6 mg per liter of CBOD, we have 8 mg per liter of BOD5, and 10 mg per liter of BOD ultimate. We have a wastewater temp of 24 degrees, an upstream temp of 18 degrees, and a downstream temp of 20 degrees. We're given the reaeration, deoxygenation constants, as well as the temperature correction coefficients, dissolved oxygen concentration of 6 mg per liter, and a stream velocity of 1 foot per second. It says, assuming the time of travel required to achieve the maximum dissolved oxygen deficit in the stream is 1.8 days, the minimum dissolved oxygen concentration in mg per liter is most nearly what? So the first thing that we'll do here is we see that it's a receiving stream in wastewater. So we'll look up the Streeter-Phelps equation. And then we can see here that we are given the BOD ultimate, we are given the time in days, and we're given the deoxygenation and reaeration constants. So what we can do with this is we can actually solve for the third equation down here, the DC. Let's write this out. dC equals K1 over K2 LO e to the negative K1T max. Okay, so with this, we're solving for the maximum dissolved oxygen concentration here. And let's make sure to remember at the end that we are actually looking for the minimum dissolved oxygen concentration. So when we get started here, K1 value in the handbook is the deoxygenation rate, which is going to be 0.23. The reaeration rate is 0.40. The LO value is given as the BOD ultimate, which is going to be 10 milligrams per liter. It's e to the negative 0.23. And then the Tmax again is this 1.8 value given here. That's days. So that value will come out to 3.8 milligrams per liter. And remember that this DC is the D max, the dissolved oxygen maximum concentration. And what we're looking for here is the dissolved minimum concentration. So we can take this last equation here in the reference manual of DO equals DO sat minus the D max. And for this DO sat value, we'll look it up in the table of the dissolved oxygen concentrations in water. And we're looking for 20 degrees here. And what we find right here is 9.08 milligrams per liter. And then we're going to subtract that max DO concentration that we got. And this will lead us to the answer of 5.2 milligrams per liter. When we go back up to the problem here, we can see B is 5.2. So you'll see with a lot of the FE and PE questions, they give you a lot of extra unnecessary information. And it's important to figure out which information is valuable for this problem. So you can see here that we have a lot of this temperature, the correction coefficients, all of these are extra information that we don't need on this problem. So it's important to understand which parts and which data from the problem is important for this end conclusion.